In a world where soils are eroding, crops are failing, and carbon is choking our skies, the solution may lie in something ancient, simple, and black as night. Beneath the Amazon rainforest, scientists uncovered soils unlike any others on Earth. Fertile, resilient, and rich in carbon, created not by accident, but by human hands centuries ago. This is terra preta, or dark earth. And at its heart is a powerful tool, now being revived to fight climate change and restore our soils. We call it biochar. So what exactly is biochar? At its core, biochar is a form of charcoal, but with a purpose far beyond fire. It's made by heating plant matter, crop residues, or wood in the absence of oxygen, a process known as pyrolysis. Unlike ash, biochar is stable, porous, and can last in the soil for hundreds, even thousands of years. When added to soil, biochar acts like a sponge and a shelter. Its tiny pores trap water, hold nutrients, and provide homes for billions of soil microbes. This not only boosts soil fertility, but also locks away carbon that would otherwise return to the atmosphere as cal. In other words, biochar is both a soil enhancer and a climate solution. Modern farming is the backbone of human civilization, but it also carries a hidden cost that few of us see. Agriculture is responsible for nearly a quarter of global greenhouse gas emissions. Putting it alongside energy and transport as one of the largest drivers of climate change. But how does farming create so much pollution? It begins with the soil itself. When land is plowed year after year, the carbon stored in the soil is exposed to air. That carbon oxidizes and escapes into the atmosphere as carbon dioxide. In fact, since the dawn of industrial agriculture, soils worldwide have lost more than half of their original carbon. Then there are fertilizers. Synthetic nitrogen fertilizers revolutionized food production, but they also release nitrous oxide, a greenhouse gas nearly 300 times more powerful than coal. Livestock add to the problem. Cattle and sheep emit methane, another potent greenhouse gas, as part of their digestion. And vast areas of forests are cleared each year to make room for crops and grazing land, releasing even more carbon and reducing the Earth's ability to absorb it. Put together, these practices form a cycle of extraction and loss. We are mining the soil for fertility, mining fossil fuels for fertilizers and machinery, and cutting down ecosystems to expand farmland. This industrial model feeds billions today, but it does so at the cost of tomorrow. The emotional truth is sobering. Farming, the very system designed to nourish us, is also destabilizing the climate that makes food possible. If nothing changes, we risk pushing our soils, our water, and our climate past the point of no return. But here's the paradox. While farming is a climate problem, it could also be one of the most powerful solutions. The way we grow our food has the potential to not just reduce harm, but actively heal the planet. This chapter sets the stage for a critical shift in perspective. If farming helped create the climate crisis, then rethinking farming could help solve it. And that's where practices like biochar, regenerative grazing, and agroforestry come in, showing us that agriculture can be more than a source of emissions. It can become a carbon sink, a climate ally, and a pathway to a more resilient future. Regenerative practices in action. When we talk about solutions, they're not theories or distant technologies. They're here, in the soil beneath our feet, in the way we choose to grow food. Across the world, farmers are proving that regenerative practices don't just heal land. They restore balance to our climate, water, and communities. Cover cropping is one of the simplest yet most powerful tools. Instead of leaving soil bare between harvests, farmers plant legumes, grasses, or clovers. These living covers protect against erosion, feed the soil with organic matter, and lock away carbon. What once was empty ground becomes a living shield, No, till farming takes it further. By avoiding the plow, farmers prevent the release of soil carbon while building deep, resilient root systems. Earthworms, microbes, and fungi thrive, creating a hidden underground network that strengthens crops against drought and disease. Composting brings waste back to life. Food scraps, manure, and crop residues are transformed into rich organic fertilizer, closing the nutrient loop, reducing reliance on synthetics, and replenishing soil fertility. Agroforestry integrates trees into fields and pastures. Roots hold water, leaves provide shade, and diverse harvests, from fruits to timber, support both ecology and economy. In landscapes threatened by desertification, tree-based systems can literally stop the spread of the desert. Rotational grazing reimagines livestock. Instead of letting animals overgraze, herds are moved in cycles, mimicking nature's patterns. The result: healthier pastures, deeper root growth, and carbon stored in the soil. Animals become allies in regeneration, not enemies. These practices may sound new, but they echo indigenous and traditional wisdom that sustained land for centuries. Science is now catching up to confirm what local communities always knew. Healthy soil is the foundation of resilience. The evidence is mounting. Farms using regenerative methods show higher yields during drought, richer biodiversity, and stronger profits. They not only survive climate shocks but thrive through them. Each cover crop, each compost pile, each tree planted is a step toward a farming system that restores instead of extracts. Regeneration is not an idea. It's already happening. The question is whether the world will follow. Biochar and climate change. When we talk about climate change, we often hear about smokestacks, tailpipes, and rising carbon dioxide levels in the atmosphere. But what if one of the solutions is buried beneath our feet? Biochar offers a rare opportunity, a way to pull carbon out of the air and lock it safely in the soil for hundreds, sometimes thousands, of years. It's one of the most promising natural climate solutions, rooted in ancient practice, but backed by modern science. Here's how it works. Plants absorb carbon dioxide as they grow. Normally, when plants die or are burned, that carbon is released back into the air. But when biomass, like crop residues, wood waste, or even manure, is turned into biochar through controlled burning, the carbon becomes stable. Instead of escaping, it stays captured inside a porous charcoal-like structure. Once added to soil, it resists decay, effectively acting as a long-term carbon bank. This matters because farming is both a victim and a driver of climate change. Agriculture produces about a quarter of global greenhouse gas emissions through fertilizers, livestock, and land clearing. But with biochar, farms can flip the script. Instead of contributing to warming, fields can become powerful tools for cooling. Beyond storage, biochar makes soils more resilient to climate extremes. Its porous texture helps hold water during droughts, while improving drainage in floods. It increases nutrient retention, reducing the need for synthetic fertilizers that release nitrous oxide, a greenhouse gas nearly 300 times more potent than coal. Globally, researchers estimate that large-scale biochar adoption could lock away up to 2 gigatons of carbon each year, the equivalent of taking hundreds of millions of cars off the road. While it's not a silver bullet, it could be a vital piece of the puzzle. The bigger picture is clear. Solutions like biochar are not just about farming smarter. They're about rewriting our relationship with the earth, shifting from extraction to regeneration. Benefits for farmers. The story of biochar isn't just about carbon and climate. It's about survival, resilience, and new opportunities in a changing world. Across regions with poor or degraded soils, biochar has been a game changer. Its porous structure acts like a sponge. holding water and nutrients where crops can reach them rather than letting them wash away. The result: higher yields, even in soils once written off as unproductive. In Africa's drylands, farmers adding biochar have seen maize production double. In parts of Asia, rice farmers report healthier roots and stronger harvests. And in Latin America, smallholders are using biochar to revive exhausted soils that no longer supported their families. The benefits go beyond productivity. Because biochar holds on to nutrients, it reduces the need for costly chemical fertilizers. That means lower input costs and fewer harmful runoff effects downstream. For small farmers especially, this savings can mean the difference between staying on the land or abandoning it. Biochar also helps farmers weather the extremes of climate change. In drought-prone regions, soils enriched with biochar hold water longer, keeping crops alive through dry spells. In flood-prone areas, its structure improves drainage, protecting plants from drowning. In both cases, biochar makes farms more resilient. There's another advantage: as waste becomes wealth. Crop residues, animal manure, even forestry byproducts that might otherwise be burned or discarded can be converted into biochar. This turns a disposal problem into a valuable resource for soil improvement, and in some cases, even into an income stream. Across the world, pilot projects are connecting farmers to carbon markets. By sequestering carbon with biochar, they can earn credits that companies buy to offset emissions. For farmers, that means new income, not from more extraction, but from regeneration. At its core, biochar offers a different kind of promise: to help farmers grow more food with fewer inputs, to withstand the shocks of a changing climate, and to find value in what was once waste. It's not just a tool for carbon, it's a lifeline for agriculture. Global experiments, from small backyard pits to industrial-scale plants, biochar is finding new life worldwide. What was once an ancient practice has become a modern experiment, unfolding in fields, villages, and factories across the globe. In Kenya, smallholder farmers are leading a grassroots revival. Using simple biochar kilns built from local materials, they convert crop residues into black carbon-rich soil amendments. For these farmers, biochar is more than just a soil booster. It's a way to grow food more reliably in the face of drought and unpredictable rains. The simplicity of the method makes it accessible, scalable, and affordable. In India, rice farmers are taking a different approach. Instead of burning rice husks, a common practice that fills the skies with smoke, they are transforming this agricultural waste into biochar. In paddy fields enriched with rice husk biochar, yields are climbing, water is held longer, and methane emissions from flooded soils are reduced. It's a local solution with global impact, tackling both food security and climate change. Meanwhile, in the United States and Europe, the story takes on an industrial scale. State-of-the-art pyrolysis plants process wood waste, crop residues, and even municipal green waste into biochar. These facilities don't just produce soil amendments. They also capture renewable energy in the form of heat, gas, or bio-oil. The result is a triple win: carbon stored, clean energy produced, and healthy soils restored. Across continents, the common thread is innovation rooted in necessity. Each region adapts biochar to its own challenges and opportunities. In some places, it is a lifeline for small farmers trying to survive a changing climate. In others, it is a high-tech solution to meet sustainability goals and carbon reduction targets. These global experiments remind us that biochar isn't one size fits all. It is flexible, adaptable, and responsive to the needs of both people and planet. Whether dug from the earth in backyard pits or manufactured in gleaming facilities, its promise remains the same: to turn waste into wealth, pollution into fertility, and carbon into hope. Challenges and criticisms. Biochar holds enormous promise, but like every solution, it comes with challenges and criticisms that must be faced head-on. First is the question of permanence. Scientists caution that while biochar can lock carbon into soils for centuries, it's not invincible. Poor quality production or exposure to erosion, fire, and tillage can send that stored carbon back into the atmosphere. The effectiveness of biochar depends not just on how it's made, but how it's used. Another challenge is scale. Supporters see biochar as a global climate solution, but skeptics warn that producing it on a massive level could require huge amounts of biomass, crop residues, wood, or green waste that may compete with other needs. If not carefully managed, large-scale production could drive deforestation, land grabs, or unsustainable harvesting. Then there is cost. For smallholder farmers in the global south, even a simple kiln or the labor required to make biochar may be out of reach without support. In industrial settings, pyrolysis plants require millions in investment, and the economics only work when carbon credits or subsidies are available. Without equitable access, biochar risks becoming a tool of wealthy nations and corporations, leaving behind the farmers who could benefit most. Critics also point out that biochar is not a silver bullet alone. It cannot reverse climate change or solve the global food crisis. Some studies show benefits tapering off after several years, especially if soils are already healthy. Others worry that enthusiasm for biochar could distract from reducing fossil fuel use or protecting forests. And yet, these criticisms are not the end of the story. They are reminders that biochar is a tool, not a cure-all. Its success depends on context, scale, and responsibility. Used wisely, it can complement regenerative farming, agroforestry, and other climate-smart practices. Ignoring the challenges would be dangerous, but dismissing the potential would be equally short-sighted. Biochar is more than just charcoal. It's a soil superpower. Produced by heating organic material like crop residues, wood chips, or nutshells in a low-oxygen environment, biochar transforms waste into a stable, carbon-rich substance that can last in soil for centuries. Unlike ordinary compost or burning, pyrolysis locks carbon away, creating a sponge-like structure that improves soil health. Picture this: a tiny network of pores in soil, silently holding water and nutrients, nurturing life below our feet. This is biochar at work, quiet, powerful, and enduring. From rice paddies in Southeast Asia to cornfields in the American Midwest, farmers are embracing biochar, witnessing healthier soils and higher crop yields. Rooted in ancient practices, yet validated by modern science, biochar holds a promising key to sustainable agriculture and climate mitigation. It's more than a tool. It's hope for our soil, our food, and our planet. Biochar's benefits are promising, but they're not guaranteed. When applied correctly, it can improve soil structure, boost water retention, and even enhance crop yields. In Ethiopia and Kenya, studies show maize and sorghum flourishing in biochar-treated soils, especially during harsh dry seasons. But here's the catch: biochar isn't a miracle. Its impact varies with soil type, feedstock, and how it's applied. Sandy soils respond differently than clay, and not all biochar is created equal. Some critics have even called it the snake oil of modern agriculture. Yet, the truth is more nuanced. Biochar works best as part of a holistic soil management approach, alongside composting, crop rotation, and sustainable irrigation. When used thoughtfully, it can become a quiet ally in restoring soils, nurturing crops, and building resilience against a changing climate. One of biochar's most exciting promises is its potential to fight climate change. By locking carbon in a stable form, biochar keeps greenhouse gases out of the atmosphere for hundreds, even thousands of years. Imagine the soil as a long-term carbon vault, quietly safeguarding our planet's future. Tune in an emotional moment. Across the globe, projects are proving this vision. In Australia, experimental farms are sequestering tons of CO2 using biochar made from crop residues. Scientists estimate that if biochar were adopted widely, it could capture billions of tons of carbon annually, enough to complement reforestation and other climate strategies. But the benefits don't stop there. Biochar also improves soil water retention and reduces the need for synthetic fertilizers, helping farms become more resilient to droughts and extreme weather. While it isn't a silver bullet for climate change, biochar is a powerful ally, a vital tool in the growing toolkit of regenerative farming and environment. Biochar turns waste into wealth. Agricultural residues, forestry scraps, and even urban green waste can be transformed into a valuable soil amendment. This is circular economy in action, reducing waste, creating value, and protecting our natural resources. Picture vineyards in California, where prunings once burned now become nutrient-rich biochar, enriching soils and cutting pollution. Across Queensland, sugarcane residues are repurposed, boosting crop resilience and opening new economic opportunities for farmers. Beyond improving soil, biochar production creates financial incentives through carbon credits, rewarding sustainable practices. By turning leftovers into long-term benefits, biochar shows how agriculture, environmental stewardship, and economic growth can work hand in hand. It's an innovation born from science, realized through practical action, and shaping a more sustainable future for our farms and our planet. Who's promoting biochar? A growing mix of NGOs, startups, and carbon credit markets. NGOs highlight its environmental benefits, startups push innovation and commercialization, while carbon markets emphasize climate potential. These voices have amplified biochar's profile. But not all claims are backed by rigorous evidence. Scalability, affordability, and accessibility remain questions. High-tech production facilities are expensive, and smallholder farmers may lack resources to adopt biochar widely. Carbon credit incentives can help, but regulatory frameworks are still catching up. Understanding who benefits and how is key to separating genuine impact from marketing hype. Biochar holds promise, but careful implementation, monitoring, and community engagement are essential for its success and credibility. Biochar isn't without risks. Its effectiveness varies depending on soil type, feedstock, and application method. Contamination risks exist if biomass contains heavy metals or chemicals. Energy use during production can offset carbon benefits if not carefully managed. Scientific skepticism and regulatory gaps remain. Researchers stress that biochar is a tool, not a panacea. Misapplied, it could lead to inconsistent results or economic losses. Awareness, quality control, and proper education are essential to ensuring biochar fulfills its potential sustainably. Understanding these limitations allows stakeholders to apply biochar responsibly, enhancing soil health, sequestering carbon, and supporting sustainable agriculture without falling for overhyped claims. The proof of biochar's potential lies in real-world impact. In California, vineyards using biochar report improved soil structure and healthier vines, while crop yields increase. Queensland sugarcane farmers note enhanced water retention and nutrient efficiency, reducing fertilizer needs. Before and after soil tests reveal higher organic matter, better water holding capacity, and improved microbial activity. Farmer testimonials highlight resilience during droughts and economic benefits from carbon credits. These cases demonstrate that, when used thoughtfully, biochar is more than theory. It's a transformative tool for sustainable agriculture. From smallholder farms to commercial operations, biochar's integration into farming practices offers hope for healthier soils, more resilient crops, and meaningful climate action.